which means it's not going to be fun, right? Let me see. Let me get the exact wording that I had here. Find the equation of the line through the point 2, 4 that cuts off the least area from the first quadrant. Ha ha ha. So I know some of you may have actually already looked at this problem, but I know maybe many of you probably haven't. Before we start this problem, let's recall, because a lot of you might look at this and like, oh my God, I have no idea what to do. No, you do know what to do. I'm here to convince you that you actually do know what to do. So let's remind ourselves, how do we solve an optimization problem? First of all, actually a better question is, how do you recognize this as an optimization problem? I mean, it's easy now because you know we're reviewing optimization. But what if this were on the final? Because the final, everything's just going to be in any old order, right? So Jacqueline says least area, least, right? The fact that it's a word problem and we have this superlative least, right? That should kind of tip you off. Oh, this is an optimization problem. Okay. So already you should be thinking in terms of what? Constraints, objectives, right? Things like that. So let's actually review very quickly. What is our general roadmap for an optimization problem? Again, I'm here to convince you that you already know how to solve this problem, but we need to, just make it for the specific one. But let's talk about generalities. How would you usually go about solving a problem like this? Find the objective. Okay, what other steps do we need? Let's see. Ayana says find the constraints. Possibly more than one. There might be more. That I'll say find constraints. Put in terms of one variable. Put in terms of, what do you mean? Put what in terms of one variable? Put the objective in terms of one variable. When you said substitute, I don't know what you mean by substitute. You never use it in this class. That triggers me so much. You know how exams and math and college and life just trigger you guys? Like the word it triggers me. Yeah, and stuff. Things and stuff. So what else is there to this problem? I mean, you guys kind of have like the first half of the problem almost. The interval of interest. Substitute into objective. That's part of that, right? Put objective in terms of one variable, right? So that's kind of already there, Jessica. Right, then you need critical points. Then you need justification. And then you need the answer. And at the very beginning, you might have a diagram to help you. So when you look at this problem, if you get scared, don't be too scared, because hopefully you know this, right? Hopefully you know this general roadmap. You can then start filling in little pieces, right? And it's kind of in two parts, right? There's a non-calculus portion, right? Non-calc, and then the calc. So you can start filling in like the little pieces, right? Think about what the objective is. Think about what the constraint is, right? Baby steps, right? If you're scared about a problem, recognize how to solve them in general, and then fill it in a little bit at a time with baby steps. I mean, yes, it's a little bit slower, and yes, more practice would get you to the point where you actually do feel more confident. But if you're not confident about a problem, that's how you should approach it, right? Okay, so let's think about this. So let's draw a little diagram here, because this is actually a tricky problem, trying to figure out what the constraint is, what the objective is. So first, before I actually give you the answer, does anyone have any insight so far about what the objective or constraint might be, or how we should start framing this problem? I'm just going to say that here's 2, here's 4. No, that's not good. Let's say 2, 4. Objective is y equals 4 plus m times x minus 2. That's not an objective, that's an equation, right? How do I recognize the objective? So Jacqueline says it's the area. How did Jacqueline recognize that a certain area was the objective, right? She looked for this superlative word least. And what is following least? Area. So therefore area must be the objective. So first of all, what area are we even talking about? That's a good question. So here's the point 2, 4. And we have some line that passes through it. And it says the line cuts off some area from the first quadrant. So here's a line, and it has now cut off some area in the first quadrant. So in other words, I'm looking at this area. It's the area of a triangle. Let's see, Margaret says point 2, 4, then draw a diagonal like on the first quadrant, which passes through 2, 4 and forms a triangle. Exactly. So we're looking for the area of this triangle. That's going to be our objective. So what variables do I want to introduce here? So b and h, base and height. Okay. So let's call this the base. Actually, I've usually called it w, only because my b sometimes looks like 6s, so I like to call it w instead of b, but whatever. And then we'll call this the height of the triangle. So my objective is the area function a of w and h, and that's 1/2 w times h. And now we need some constraints. What are you thinking here? So constraint is the line passing right. So one of the constraints is that the line has to pass through 2, 4. Now, how do we express that? That's actually the challenge here. How do we use that constraint in an equation? Pythagorean? Well, not really, because I don't know the length of this hypotenuse, right? Okay, so this is where Jessica had the right idea. Jessica actually is giving us the equation of this line. If this line has to pass through the point 2, 4, that means this line has to have the equation y equals 4 plus m times x minus 2. Does everyone agree with that? So the fact that line passes through 2, 4 means line has equation y equals 4 plus m times x minus 2. M is the unknown variable here, which would we switch out x and y for w and a? No, 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 no. Let's be very careful here. Actually, that's a good question, Yana. What are w and h? First of all, x and y are coordinates on this line. So any point over here can be described by this line. W and H are different. W and H are specifically the base of this triangle and the height of the triangle. So in other words, actually, W would be over here. W is the x-intercept of the line, and H is the y-intercept of the line. So W and H are not the same thing as x and y on this line. They have formulas. They're the intercepts. Margaret, it's a little bit too early, but save that. Okay. So I'm gonna note that. So the slope m is the unknown. Okay, so now let's get w and h. Let's solve for w and h. So now find w and h in terms of m. So this is just what Jessica said in the chat, if you read what she wrote. So now to get w and h in terms of m, we're going to use the fact that the point w0 is on the graph. All right, let's actually write that. So this is the point w0, and this is the point 0h, and this is the point 24. So we're going to use the fact that w0 and 0h are points on the graph as well, given our definition of w and h. So w0 being on the graph means what? That 0 equals 4 plus m times w minus 2. So solving for w gives me what? W equals negative 4. What we got? Negative 4 equals m times w. I want to solve for w in terms of, so negative 4 equals mw minus 2m. So negative 4 plus 2m over m. Okay, so negative 4 plus 2m over m. Now we use the fact that, so this will be easier, the other one, the fact that 0h is on the graph. That's h equals 4 plus m times 0 minus 2. So that gives us right away that h is 4 minus 2m. Questions so far? So the tricky thing about this is it was unclear what the variable was going to be, right? But we took baby steps, right? We wrote the triangle, we wrote the area in terms of width and height because that's how we know how to write the area of a triangle, width and height. Then we use this constraint. And the only way to really use the constraint was to think about an equation of that line. And then that's where we got tipped off. Aha, that means the slope must be kind of the parameter or the unknown for this problem. You can actually think about it like this. You know, the line has to pass through 2, 4, right? So think of that as kind of an anchor point. And what are all the possible lines? Think about like kind of rotating the line around this point, right? I can have a line like this. I can have a line like this that'll make a different triangle. I can have a line like this that'll make a different triangle. All right, the triangle just has to pass through that one point. So as you rotate the line about that point, you get different triangles. And somewhere in between, we get a triangle of least possible area. That's what's happening here. So it makes sense for the slope to be the unknown because that's describing, how much we've rotated the line. Okay, but now I have w and h. So now let's go back to my objective function. So our objective in terms of m is, so let's call this f of m. And that's going to be the area function. W is negative 4 plus 2m over m. H was 4 minus 2m. So we get 1/2 times negative 4 plus 2m over m times 4 minus 2m. If you actually notice, negative 4 plus 2m is really negative 4 minus 2m. So this is actually negative 1/2 4 minus 2m squared over m. But I'm actually not going to write it like that. I'm just going to expand everything out. So if you expand everything out, you get 1 over 2m times, let's see, 16. So negative 16. What the hell do you got? Let me put the negative over here. 16 minus 8m, right? 4 times 2 times 2. Sorry, that's another 16. And then plus 4m squared. Okay. So we get here -8, and now I'm just going to expand this in. -8 over m plus 8 minus 2m. Okay, good. So that's what you get when you multiply everything out. Let me check my notes. Yes. So that's just a little bit of algebra, right? Everyone can do algebra. And now, who had it? Margaret had it, right? Now this is where Margaret comes in. She's now going to tell us what the goal is, or the interval of interest. Goal, I want the least area, right? So find, actually, I wanted the equation of the line. So find value of m that gives absolute minimum of my function. So this is my function, -8 over m plus 8 minus 2m. And now Margaret's going to tell us what the interval is. And Jessica's also told us, right? M actually has to be less than 0. So the interval is going to be -infinity to 0. Can I include 0 here? Actually, that's a good question. Does m equals 0 make sense? Is m equals 0 a possibility for this problem? No, right? Because m equals 0 will be a horizontal line, and there's no triangle. Also notice that, so any negative slope will do the job. Any negative slope, even if it's super, super, super tiny, will eventually give me an x-intercept and a y-intercept. But no positive slope will do it, right? A positive slope will not make any triangle. So we are not only allowed to consider negative slopes for this problem. Any questions so far? One of the reasons why this is difficult is because we originally had a W and H, and we don't write W and H in terms of each other. We actually wrote W and H in terms of this third variable M, which kind of made a little bit of a challenge. But that's okay. Okay.
Professor G?
Yes.
I mean, Dr. G. So I think like what you did was like you found.
Well, actually, I am a professor, but yeah, go ahead.
So I guess like what you did was you found the points of W and H, and then you substitute it into the equation.
Yes. The big thing here was understanding I wrote my area in terms of W and H, but then I had to write them also in terms of M, because the only way really to include that constraint that the line passes through 2, 4 was really writing a general equation for that line. And the only way to do that is to leave that slope unknown. That was the key. It really came down to how do I incorporate that constraint into my problem? And that kind of forced our hand.
Okay.
Yeah. Why -infinity to 0? So we just discussed that we can't have a, Sasha, are we allowed to have a positive slope? A positive sloped line through the point 2, 4 would never create a triangle. So you can't have a positive slope. But any negative slope will create a triangle. Okay. Now the rest of the problem should be pretty straightforward, right? Once you have it down to this point, you should be like, aha, finally, I could do the calculus, right? That first part of the problem is always tricky. So now let's find our critical points. So let's see, my derivative is -8 over m squared minus 2. Whoops, that's actually not -8, it's +8 over m squared, my bad. Minus 2 equals 0. And so I solve this and I get m equals -4. No, m equals, what the hell am I doing? I get m equals -2. Sorry, I get m equals -2 or m equals 2, right? Because when I take a square root, I'll get 2. However, m equals 2 is no good, right? I can only have a negative slope. Now what do? I found my critical points. That's the answer, m equals -2, right? Do I know that that's the answer? Well, what's always that last important step, Caleb? Because I see you're typing. You can also just use your voice. But,
you
I
gotta
guess I'll just type.
use the stuff we learned from like the past
Stuff.
lectures.
Stuff.
Like the
Stuff.
sign charts. The sign charts.
Stuff.
Sign charts.
Sign charts.
Yeah.
Okay, so we can either use the first derivative. Right, again, it says it's not guaranteed, so we choose a sign chart. So there's two possibilities. Let me go over both of them just so you can see them. So now we justify. So now justify the minimum actually exists. And we have two options. I want to make clear that both of these are options. You choose one or the other. You don't do both because they give you the same thing, right? So there's option one, use f prime of m. And so that we would use a sign chart. We don't go past 0. And our cut point is -2, right? So let's choose test points. So f prime of -3 and f prime of -1. So f prime of -3 gives me what? 8/9 minus 2. And that is what? That's less than 0, isn't it? And f prime of -1 gives me 8/1 minus 2, and that's bigger than 0. So I get here negative and then positive. So decreasing and then increasing. So x equals -2 is local min. Or I can use the second derivative. So again, the first derivative is right there, circled at the top of the screen. So finding the second derivative, I get here, that's -16/m³. And what is important here, I really just want to look at what is f double prime of -2. F double prime of -2 is -16/-8. That's 2, and that's positive. Why is that good? Positive second derivative means what? Concave up, right? So whatever you found must have been a minimum, right? Concave up looks like a U, and that gives you a minimum. So f is concave up near x equals -2. Sorry, it's not x. I keep using x. It should be m, right? So m equals -2 gives local min. And again, you can use one option or the other, whichever one you like. There's really no preference. Okay, so now that we know that the minimum exists, we're all good. Right, since m equals -2 is the only critical point, it must be m equals -2 gives the absolute min. Okay. And then just make sure you actually answer the question. Please don't come all this way and then stumble the last like 2 feet of the race. The question actually has to find the equation of the line that gives you the least area. So make sure you report the equation of the line. So the equation of the line the equation of the desired line is, so the slope was -2, and it passes through the point 2, 4. So 4 minus 2 times x minus 2. So that's the equation of my line. Oof. Questions about any part of this problem? Do you think that was a hard problem? Do you think it's harder than the other optimization problems we've been doing? What do you guys think? Was that tricky? Yeah, I think it was a little bit trickier than the other ones. Yeah. Yeah, it's confusing at first, right? When you, that's why I brought up, you do know how to solve this problem. I think when you first look at the problem, it's confusing, right? Because I can still remember when I first saw this problem, say in like high school, I remember even still thinking, how do I even incorporate the constraint right? How do you incorporate the fact that this line passes through 2, 4? It's unclear. But once, I hope I've tried to convince you, or I hope I've convinced you that if you just do it in baby steps, eventually things start to click, right? Don't just think, I don't know how to do it, so I am giving up, right? Draw a diagram, draw the triangle, think about what you know, right? What did we do first? We actually started in a direction that really didn't make sense. We started with, let's write the area of the triangle in terms of W and H. But then we thought, well, how am I going to incorporate the constraint? And then that's where the slope came in. And then we said, okay, let's write W and H in terms of the slope, right? So we kind of started in the wrong direction, but then we corrected ourselves, right? So it's okay to kind of do it in baby steps and not know what the final answer is before you start. That's the whole point. You don't know what the final answer is before you start. But I will admit this is a little bit trickier than the usual fare of optimization. But it doesn't make it too hard. It's still good enough for the exam.